Okay, so in this video we're going to look at some math operations with the binary number system, and in this video we're just going to be looking at addition and subtraction. We could also go into multiplication and division, but we're not going to go into that in this video. We're also going to look at ones and twos complement with binary numbers and look at how that is used to do subtraction with binary. Alright, so let's just look at the basic operation for addition. So here at the top I have the basic addition operations. So since it's binary, there's really only a few options as far as doing basic addition, because with binary it's just 0 and 1. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 2, which in binary that is 1, 0, right? Because 1 is as far as we can go per single place value in binary, so we have to use another place value. Alright, so here I got just a couple of examples to add some numbers here. So in this first one I got 101 plus 10. So 1 plus 0 is 1. 0 plus 1 is 1. And the 1 here just comes down. So my answer is 111. On this one I have 1 plus 1 is 2. So that's 10. So I write a 0 and carry the 1. I have 1 plus 0 plus 1, so that's 2 again, so that'll be a 0, carry the 1. I have 1 and 1 is 2, so that's a 0, carry the 1. 1 and 1 is 2, 0, carry the 1, so that 1 just comes down. Alright, so in this one I have 1 plus 1 is 2, so that's a 0, carry the 1. That 1 just comes down because it's 1 plus 0 plus 0. Here I have 0 plus 1, so that's 1. 1 plus 1 is 2, 0, carry the 1. 1 and 1 is 2, 0, carry the 1. 1 and 1 is 2, 0, carry the 1, bring that down. Alright, and then the last one here, 0 plus 0 is 0. 1 plus 1 is 2, so it'll be 0, carry the 1. Now here I have 1 plus 1 plus 1, so that is 3. So in binary, 3 is 1, 1, right? We have a 1 in the 2's place and the 1 in the 1's place if we're looking at our binary number line. So that'll be a 1, carry the 1, because it's 1, 1. So here I have 1 and 1 is 2, so that's 0, carry the 1. 1 and 1 is 2, so that's 0, carry the 1, and that gives me a 1 out there on the end. Alright, so if you want to check yourself with this, you can always convert these numbers back to decimal if you're unsure of yourself. So this one, imagine our number line up here, 1, 2, 4, so 4 and 1 is 5. And 1 in the 2's place is 2, so 5 plus 2 is 7. So we did that right, because that's 4 plus 2 plus 1. Okay? So here I have 8, 4, and 1, so that is 13. And I have 2 and 1, which is 3. And if I count this over, 1, 2, 4, 8, 16. So 13 plus 3 is 16. Alright, so this one here, if I count over, 1, 2, 4, 8, 16, 32. So 32, 16, 8, and 1 give me 57. And 4, or 8, 4, and 1 is 13. So 57 plus 13 is 70. So 1, 2, 4, 8, 16, 32, 64, and 4 is 68, and 2 more is 70. And the last one here This is 30 and this is 6. So this is 36. 1, 2, 4, 8, 16, 32, and 4 is 36. Okay? So that's just the basic operation of addition with binary numbers. Alright, so how this actually works involves a little more than just that. So first of all, let's look at some terms when we're dealing with binary numbers. So every single place value in the binary system is referred to as a bit. Okay, every single binary number is referred to as a bit. So just like we call it a digit in decimal, it's referred to as a bit in binary. Alright, so the lowest value number, or LSB, is the least significant bit. So that's the one that carries the least amount of weight. And the most significant bit, MSB, is the highest value. So it carries the most amount of weight. Alright, and then a couple other terms here. Byte, which refers to a group of 8 bits. Okay, so if we have 8 binary numbers together, that's referred to as a byte. And if we have 16 bits, or 2 bytes, that's referred to as a word. Okay, so this is what's used to organize memory for computers and programming and that sort of thing. So those terms are used quite often to represent that. So a word is 16 bits, a byte is 8 bits, and a single place value is just a bit. Alright, so looking at this example here, I've got a binary number here that is 16 bits. So that is a word, and so there's 2 bytes within this word because I can divide that up into 2 and get 8 and 8. And again, every single place value is a bit. So the least significant bit is always going to be right here, which is the ones place, because it carries the least amount of weight. The most significant bit is going to carry the most weight. So that's going to be out here at the end, 32,768. Okay, so that's what the least significant bit and most significant bit is with a binary number. Alright, so to do subtraction, we use a signed number system. Okay, so what I mean by signed is that it is numbers that are positive and negative value. Alright, so we indicate this by using the most significant bit. So that is our sign bit. Okay, so that tells us if the number is positive or negative. Alright, so if the most significant bit is a 0, then the number is positive. If the most significant bit is a 1, then the number is negative. So it does not use the positive and negative symbols to represent that like we would do in our decimal system. It uses that most significant bit's place value to indicate it. So this one right here is a 1. So that means that it's a negative number. So how that actually works is 32,768 is actually negative 32,768. So everything else, every other place value is worth a positive number, but that most significant bit is negative. So if there's a 1 there, that means we've got to subtract 32,768 from whatever these add up to be. Alright, and that gives us a negative value. So we can do this real quick and see what this number actually is. So we got 4,096, we've got 1,024, 512, 32 plus 4 plus 1 is 2,069, and we can subtract 32,768. So this number is actually negative 30,699. All right. Is what it's actually worth. So that's how we get positive and negative numbers with binary numbers. So that's how we can do subtraction with our binary numbers. Okay, so we don't use that positive and negative sign to do that. All right, so to do this, we have to do what's called complementing numbers. And no, I don't mean you walk up and tell it it's looking good today. That's not the type of complimenting we're doing. Sorry. Bad joke. I can't help myself. Alright, so when we're talking about ones complement, all we're doing is switching the numbers. Alright? So this allows us to take a positive number and change it into a negative number or vice versa. So this is what's going to allow us to do subtraction. So we're going to add a positive and negative number. Alright, so to do ones complement, I just take the number and write the opposite. So here, I just take this number and write whatever's the opposite. So the 1 becomes a 0, 0 becomes a 1, 0, 1, and 4 zeros. So that is the ones complement of this number here. Alright, so the second one, 0 becomes a 1, 0, 0, 1, 0, 0, 1, 1. So that is the complement of this number. Alright, so if this is a positive value number, and I know that because this most significant bit is a 0, now it is a negative number because there's a 1 in that place. Alright, but that doesn't truly get us to where we need to go. Alright, so if we look at back to this example over here, if we add up all of these numbers all the way up to 16,384, we're going to be one short of what this number is. So if there's a 1 in every single place value in all of these positions, that's only going to give us 32,767. So we're going to be off by 1 when we're converting that number. So to fix that problem, we do 2's complement. Alright, so basically one's complement is just the first step in the process. So here's a couple of examples here. So the first step in this is to do what we did up here, is just reverse all the numbers. So I've got 1, 1, so that's 0, 0, 1, 0, 0, 1, 1, 0. Alright, so that's the ones complement of that number. So to make this 2's complement, you add 1 to it. Alright, so that means that this will actually be 0, 0, 1, 0, 0, 1, 1, 1. So that is the 2's complement of the original number. So that will get it in the correct format that we need. Alright, so here's a positive number. So if I want to make it negative to do true subtraction, to add a positive and negative number together, so I'll make that 1, 1, 0, 1, 0, 0, 1, 0. Add 1 to it, so the 1 will go right there. So that'll be 1, 1, 0, 1, 0, 0, 1, 1. So that is the 2's complement of that original number. So this will be the number that we use to do subtraction. Alright, so these last couple examples are going to be doing the addition and subtraction with the signed numbers. Alright, so just looking at these, you don't know that it's signed numbers, so you have to be told that. Alright, but if you look at these first examples, you'll see that the most significant bit on all of these numbers are zeros. So that tells you we're adding 2 positive numbers. Alright, so I have 0 plus 0 is 0, 0 plus 0 is 0, 1 and 1 is 2, 0 carry my 1, 1 and 1 is 2, 0 carry the 1, 1 comes down, 1 comes down, 0, 0. Alright, so I'm adding 2 positive and my answer is positive. Alright, so on this one I have 1 and 1 is 2, 0 carry the 1, 1, 1, 1, that's 3, so that's a 1 carry the 1, 1 and 1 is 2, 0 carry the 1, 0 carry the 1, 0 carry the 1, 1 comes down, 0, 0. Okay, so I can again convert these. Alright, so this is 36 and this is 12, so my answer is 48, and here this is 27 and 7 to give me 34. Okay, to check your answers you can convert these of course back to decimal to check that. Alright, so now we're going to look at doing subtraction with signed numbers. So in these examples I've already done the 2's complement of that second number. Alright, so I'm not doing the whole procedure at one time, but that's certainly what you would have to do. You'd have to take that number and make it negative. Alright, so here I'm just going to add these values. So 1 and 1 is 2, 0 carry the 1, 1 and 1 is 2, 0 carry the 1, 1 comes down, 1 and 1 is 2, 0 carry the 1, 1 and 1 is 2, 0 carry the 1, 0 carry the 1, 0 carry the 1, 0 carry the 1, and it comes out here. Now, with this, we have went past what our system is in. So here there's 8 values. We've went past that. So technically this number out here doesn't exist. So this answer is actually positive because there's a 0 in the most significant bit. So if we convert this, this would be a 9 and this would be a negative 5. So we're adding 9 plus a negative 5 to give us 4 as our answer. So 1, 2, 4, and it's positive. So that is our answer. So that's how the subtraction works. Alright, so on this one here, do one more. So 1 and 0 is 1, 1 and 0 is 1, 0 and 1 is 1, 0 and 0 is 0, 1 and 1 is 2, carry the 1, 0 carry the 1, 0 carry the 1, 0 carry the 1. So again, this one is outside of the system, so it doesn't exist. So our answer is a positive 7. So this top number, 0, means it's positive, which comes out to be 19. This one is negative, which actually ends up being negative 12. So I'm adding 19 plus negative 12 gives me 7. So that's how subtraction is actually performed with binary numbers, is by adding a positive and negative value. Alright, so hope that helps, and you better understand how to do signed numbers and complementing with the binary system. If you have any more questions, just let me know. Look through the notes that I have on Blackboard. And again, hope this helps. Thank you.